Good morning. This is Dr. Shaik Maheboob, Associate Professor in the CSC department. Uh, Today we'll discuss about the software development life cycle, various types. Like in the previous class, we discussed about the software development life cycle. So today we'll discuss the various types of that type of the models. So in the previous class, we discussed what is the meaning of the SDLC, what are the 7 phases of the SDLC, and now today I will discuss the different types of SDLC. So software development life cycle process models. So we are having the waterfall model, which is also called as the basic model in the development of a software. Then we have the incremental models. Under this one, we are having the two types of model. One is the incremental model, and other one is the RAD model, rapid application development model. Then we are having the evolutionary process models. Under this, we are having the three types of model: prototyping model, then spiral model, concurrent model, and finally we have the unified process. So today we'll discuss about all these type of the process models. So one by one we'll see what is the usage of the each model and what are their advantages and disadvantages, etc., with their diagrams. So we'll start. First one is the waterfall model. So why it is called as the waterfall model means, because each and every phase means after every stage it is going to go for the next stage. So we'll discuss. So waterfall model is a basic model. It is also called as the linear sequential model or classical life cycle model. It is a basic software development life cycle model. So it is the one of the oldest model. So this model suggests a systematic and sequential approach to the software development. So the software development starts with the following phases in this one. So starting from the requirement gathering. So in this one we are having these following phases like SDLC, starting with the requirements gathering. Then we are having the analysis, design, then coding, then testing, operational development, and maintenance. So in the previous session we discussed the requirements. So first phase in the waterfall model is requirements. So where we need to gather the requirements from the clients or the customers. Once the requirements are gathered, then we will go for the analysis of the requirements. So in the analysis phase, we are going to find out the total period, means total cost, effort required, total time required, and what are the team members required, etc. Each and everything is analyzed in the analyze phase. Then once it is analyzed, then it is forward to the next team, that is the design team. So in the design team, they are going to produce one type of architecture or the structure. So in this one, one type of architecture or the structure is prepared. So in this it will help in finding, or you can say it will help in specifying the hardware and system requirements, and also helps in identifying or defining the overall software architecture. So once the design phase is completed, it's forward to the next phase, that is the implementation or the coding part. So in which by taking the inputs from the design, the system is first developed in the small parts, like small programs will be there, which we called as the units. Each unit is developed and tested for its functionality, so which is also called as unit testing. Then once it is completed, coding part is completed, we are going to merge, or you can say we are going to integrate the all the coding part. So in this next phase is the integration and the testing. All the units which we develop, like small unit or small programs, we are going to integrate, right? All the units developed in this implementation phase are integrated in the implementation and means integrated into this phase. So after that one, we are going to perform the software testing. So the entire programs, whatever the programs or whatever the code we have developed in the implementation phase, we are going for the testing. So once testing is completed, so and after the testing of the entire system, we are going to find out any bugs, defects or errors. It is noted down. Then after this one, next phase is the deployment. So in the deployment phase, after completion of this testing phase, we are going to release the product into the market, or we are going to deliver the product to the customer or the client. So in the deployment or the operation phase, we are going to deliver the software to the customer or the client, or releasing the version in the market. Then last and final phase, which will take the around 60%, or you can say total 60% of the total cost of the project, will be mainly dependent on this maintenance. Why? I will tell you. So in this maintenance phase, whatever the bugs, defects are there or errors are there, we are going to do or resolve these issues in this maintenance phase. So whenever a client or the customer finds any types of bugs or defects, then they need to send this report to that maintenance. So to fix those issues, patches are released. So also to enhance the product, means suppose you want to extend its version or update the version, that time also this phase is important. So maintenance is done to deliver these changes in the customer environment. So why it is called as the waterfall model means, because once it is completed, it is going to do, so it is going to means one phase completed, it will go to next phase. Then after that, simultaneously you can see, so the pattern is taking as a waterfall. That's why it is called as the waterfall model. Okay, so now we'll see about its advantages and disadvantages and the usage. So advantages for waterfall model is, it is very simple and easy to use, very easy to understand, and it is a simple classical model and works well for smaller projects. So usually we can use this type of model for the smaller projects, and clearly defined stages. So as we discussed, requirement analysis, designing, coding, testing, so each phases are clearly defined stages, easy to arrange the task. Then process and results are well documented. So this software model or process model is used for the smaller projects. Then in addition to this, we are having some disadvantages of this process model, like a high amount of risk and uncertainty, not a good model for large softwares and object oriented projects, cannot accommodate changing requirements. So it is difficult to measure the progress within the stages. So why this model is not preferred for larger project means, so if you go through this following phases in this waterfall model, so we don't have any means, suppose anyone is find any type of the error, they cannot report it to the previous team. So requirement is done by one team, analysis done by one team, design, coding, testing and deployment, maintenance. So each phase is carried out by different teams. So suppose any problems are there, suppose any team find out that if any errors or bugs are there, then they cannot report it to the previous team. So that is the major disadvantage, and it cannot be used for the larger projects. So when they will know, so when they will release the software, then when they release the software or deliver the software to the customer, then only that errors, bugs can be find out. So that is the major disadvantage of this waterfall model, and it cannot be used for the large projects. So no feedback, you can say, from the previous teams, or we cannot have the responses to the previous teams. Okay, so that are the some of the disadvantage of this waterfall model. Now next one is the incremental model. So in this incremental model the requirements are there. So in this we are having the two types of model. One is the incremental model, another one is the RAD model. So in the incremental model, the requirements are divided into multiple modules. So it means what, whatever the requirements are there, it is divided into the some type of some parts, you can say, right? So in each module we have all the phases that are analysis. So after dividing the requirements for each type of the, you can say, module, we are having the analysis, design, coding and the testing. So this model used for the software with less features and used in day to day applications. For example, in the banking sector we can say, right, or if they want urgently, so that type of applications can be developed with the help of this incremental model. So for this type of model, a less type of the you can say manpower is less manpower is required. So as I said, two models are there, incremental model and the RAD model. So we'll discuss that two model in this incremental model. So first one is the incremental model. So in this phase, the software development will be carried out. As I said, the requirements are divided into the number of the modules, and each and every module is you can say developed separately. So we are going to design, we are going to do the analysis, we are going to go for the design, we are going for coding and testing separately for each module. So once it is completed, then we are going to add it. So that's why if you observe the diagram, for each iteration process, suppose one is there, then in the second iteration you see each iteration process through the requirement, design, coding and testing phases, and each subsequent release of the system adds some functionality to the previous release. It means, like, take one example about the Samsung sorry Android application, this one Android software. So previous version, say suppose 13 version is there, and we want to add some more features, then we can go for Android 13.1. So like that type of the versions we can able to add it with the help of this type of the models. So for each type of the release with the added features, you can say we can release the software into the market. So that's why whatever the bugs, defects, errors are there in the previous version, we can going to resolve that defects, bugs or errors, and we are going to release into the market. So that is the advantage of this incremental model. So this is the diagrammatic representation of this incremental model. So as I said, after taking or after dividing the requirement into the different types of module, each module is separately analyze, design, coding and testing. So we call it as the increment 1. Then similarly for other module, increment 2, increment 3. So in this way we are going to carry it out. So if you want to add the features, any new features, then we can able to add the new features in this incremental model. So when we can use this type of the model, so some of the points are there. When the requirements are clearly understood, means we customer or client requirements are well known and easily understood, you can say, or clearly understood, then that time we can able to use this incremental model. When demand for early release, like I said about the Android version, they want to release some 13.5 or higher version, then if there is a urgent need, or you can say requirement, then we can go for this type of the model. So when demand for an early release of the product arises, and when software engineering team are not very well skilled, means all the team members, they don't have the technical knowledge about how to develop, means they are having very less knowledge, then that time also we can use this type of the models. When high risk features and goals are involved, such methodology is more in use for web application and product based companies. So these are the some points about incremental model. Now advantages, like how we have advantages and disadvantages for these previous models also. Same way here also we are having some advantages and disadvantages for this incremental model. So in the advantages, early delivery, first advantage is the early delivery. So it will allows the early release based on the, you can say, if there is a urgent need of the software, if there is a demand, then we can go for this type of the model. That's one of the advantage. Early delivery allows for the early release of partial functionality to the users. Then feedback integration is also there, like incorporates user feedback iteratively, leading to the product quality. Means by taking the feedback from the teams, previous teams, or the each module team, we are going to improve the quality of the product. Then risk can be reduced with the help of this model, like risk reduction, smaller manageable increments uh, reduce the overall project risk. So we can reduce the risk. Then easier testing is there, as we are going to divide the requirements into the number of the modules, so easily we can going to test each module. So that are the some of the advantages. Now some disadvantages also there for this incremental model, that is complex management, that is require careful coordination. So as we are going to develop into the separate modules, so that's why it requires careful coordination and tracking of the multiple increments. So each time we need to coordinate. Then potential higher potentially higher cost. So initial investment in the this flexible architecture can be higher. So that is the major disadvantage. Incomplete features. So if we are going for this like early release, that time also some critical features may not be available in the early increments. Then dependency challenges are there, that is dependencies between the increments can cause issues if it is not managed well. Then documentation overhead. So managing documentation for each increment can become a cumbersome. Means it is very difficult, because if there is no coordination among the different teams, then that can be difficult to maintain this documentation. So that are the some of the disadvantages of this incremental model. Now next one is, in this second type we are having the RAD model. So RAD stands for the rapid application development. So RAD model it is also one of the incremental model, so in which very short development life cycle is there, like SDLC, very small SDLC process is there. So we can develop within the period of 2 months or 3 months, right? If there is a demand from the client or the customer that they need a software urgently within 2 months, 3 months, that time we can go for this type of the model. So to do this one, suppose urgently if we want to deliver, means the multiple teams are there, they are going to do the work and develop the software by using this model. So the diagrammatic representation is also there for this RAD model. So as if you can see the requirement, after the requirement analysis, the model is going means in this phase you can see here we are going for the design implementation testing. So like in the format of the increments, you see each phases we are going to do this type of the development, like similar to the previous model only. After the doing of the this requirement analysis, in the second stage you can say we are going for designing, implementation and testing. Then once it is completed, all the, you can see here all the uh, different types of modules are merged and going to deliver, or we are going to integrate into the format of the one software. So that is why this type of the model is used when there is an urgent need, so which can be developed within the short duration of time. Okay, so in this the requirement gathering, we discussed that gathering, the developers communicate with the users, right? So in this, after taking the requirement, means from the client or the customers, we are going to forward to the next stage, right? So after that they understand the requirement about this client or the customer, then they are directly forwarded the complete analysis of the SRD, software requirement document, to the next stage. So during this analysis and this planning phase, the analysis on the gather requirement is made, and a planning for various software development activities are done. So during this as I said, design, implementation and testing. So design, one type of architecture or one type of a structure of the software is developed. Then after that, in implementation part, coding the small programs, right? The programs are there with the help of any programming language. Then testing are performed, right? So the so after each build, so as I said, suppose this is one phase, so one module, so we call it as the one type of a build is there, right? So build 1, build 2 and build 3 are there. So here you see, the build is an activity in which the existing software, right? So previously one team have developed this software. Then in the second build, whatever the bugs, issues, or you can say defects, errors are there, they are going to remove. So that's why the build, in the format of the build, they are going to develop and deliver to the customer. So the build is an activity in which, using the existing software components and automatic code generation tool, the implementation code is created for the software system and it is tested. So as I said, after the completion of this one, if any type of the features are not added, we can complete in the second build. If it is not completed in the second also, then we'll go for this one and we can going to deliver to the client. So the functionalities which are developed by all the teams are integrated to form a whole software, as I said. So whatever the features adding, so all the things are integrated and we are going to form a one type of a software. So finally the deployment of all the software component is carried out. So after completion of all the builds, after adding the additional features in each build, then we are going to form a software and we can go for the deployment, that is delivery of the software to the client or releasing of the software into the market. So when to use, some of the points are there when we can use this RAD model. So in this one, so when the time period is there or there is a demand that customer or client want within a short duration of time, then that time we can use this RAD model. Then when the requirements are well known or understood clearly, when the technical risk is limited, then it should be used only if the budget allows the use of automatic code code generating tools. So some of the advantages and disadvantages are also there for this RAD model. That is, this model is flexible for change. Changes are adaptable, means customer can change his requirements, right? Even after giving the all the types of its his objectives or what he required, the client or customer can do the changes. So in each phase in RAD brings highest priority functionality to the customer. So how it is going to be work out, functionality means they are going to give the highest priority to the functionality to the customer. So after the, you can say, development of one build, there is an involvement with the customer, you can say. So they are going to communicate with the customer and they are going to say like any type, any extra features or anything which they want to remove, like that the communication is with the customer are there. So that's why highest priority functionality to the customer, and it reduces the development time and it increases the reusability of the features. Now some of the disadvantages of the RAD model is there, like it required the highly skilled designers because as it is needed in the short duration of time, that's why high skilled designers are needed for the development of this application software. So for smaller projects we cannot use the RAD model. This is also one another disadvantage of this RAD model. And on the high technical risk, it's not suitable and required the user environment. User environment means what? Customer requirement is there. So we can't say that customer or client is available all the time during the development of the software. So that's why that is also another disadvantage of the RAD model. Now last one is the third type of the models is the evolutionary process model. So why it is called as evolutionary process model? So in this evolution process model is a combination of some iterative models, or you can say one version is completed, second version, then third version, like that. So it's a combination of what we discussed till now, that is iterative and the incremental model of a software development life cycle. So in this one, we are having the three types of the models, that is prototyping model, spiral model, and concurrent development model. We'll discuss these two these three types one by one. So first one is very easy concept about this prototyping model. So why it is called as prototype model means, so if you observe the diagram carefully, after the gathering of the requirements from the customer, so what is there, there is a one type of a quick design is there. So this is also one of the you can say software development lifecycle model. So in which we are going to develop one type of a prototype with the minimal requirements. So after taking the requirements from the customer, there is a one quick design is prepared. Now after that one, based on the design, a prototype is developed. So after that one built prototype, there is a important phase is there, that is customer is going to evaluation that prototype, means whether the customer is satisfied with that prototype or not. So after the design, after the development of the prototype, there is a involvement of the customer. So in this one, the customer is going to check whether the design or this prototype is correct or not. So if it is satisfied, then only it is forwarded to the other design or other phases, you can say. If customer is not satisfied with the prototype, then they are going to refine the requirement, and they are going to see the some take the customer suggestions, and again it is forwarded for the design phase, means that is the quick design phase. Again there is a prototype is developed. So same way, the one type of a cycle is there, until and unless the customer satisfied or customer acceptance, it is not forwarded to the next phases. So that's why it is also, it's called as the prototyping model. So one type of a prototype is developed, and here, so prototype development is there. Then remaining are the what we discussed in the previous model, that is iterative development. So once the customer accepted the prototype, then it is forwarded to the design phase, so where we are going to develop one type of a architecture for the software. Then once it is completed, then we'll go for the coding part, so where the programs or the programming with the help of any programming language, the programs are completed. Then once it is implemented, the next phase is the testing, that is similar to the what we discussed in the previous model. We are going to check with the verification, validation, and with the valid inputs and invalid inputs, we are going to perform unit testing, integration testing, right? So we are going to check the code and check the functionality of the software. So once it is completed, finally we are going for the maintenance, that is delivery of the this product to the customer, and we'll go for the maintenance phase. So the important part is in this prototyping model is, after the taking the requirements, it is going for a quick design, and we are going to develop one type of a prototype, and we are going to take suggestions, or we are going to you can say evaluation, customer evaluation of the prototype is taking place, right? So that is all about your prototyping model. So we discuss in this these are the some of the phases, like initial communication what we discuss, that is, so they are going to collect the requirements. So like requirement gathering, business analyst, or you can say other individuals in the company, they are responsible for taking the requirement, and they are going to discuss the need of the clients. Then based on that, quick design is there, so quick plan. Then once basic requirement have been discussed, quick plan of the initial prototype is made. So modeling of the quick design, what we discuss after requirement gathering, that is quick design is prepared. Then that is the UI part, designing part of the prototype is carried out in this phase. Then development of the prototype, that is the design prototype is coded and develop, right? Finally, what we discuss about this, once if it is accepted means we can go for this further steps. So same deployment, delivery and feedback of the prototype will be carried out. So whatever the based on that prototype, the customer can suggest some of the like features or about the any type of the modules, sub modules, right? So based on that suggestion feedbacks, they are going to go for the other phases. So that part is important in this prototyping model. Now after that one, after the deployment and feedback of the prototype, then final product design, coding, implementation and testing and deployment, delivery of the application and maintenance are there. So what we discussed, the remaining phases, that is the iterative development, are completed. So that is all about your prototyping model. So these are the some of the advantages and disadvantages of the prototyping model. So in this one, advantage is what, the prototype model need to know the detailed input and output process. So that is adaptability of the OS and full machine interaction, and that is the advantage. Then in the development process in this model, users are actively involved. So as I said, after the requirements gathering, quick design is there, so there is an involvement of the customer is there. So that is the major advantage. We can discuss with the client or the customer whether it is he or she satisfied with the prototype or not. So that is the advantage of this, users are actively involved. So the development process is the best platform to understand the system by the user. So if we are involving the customer or the client, it means what, we are going to get the clear requirements, clear objectives of the software project. So error can be detected much earlier and gives quick user feedback for better solution. As I said in the diagram, so customer can gives his suggestions for the evaluation after the evaluation. So it identifies the missing functionality easily, right? It also identifies the confusing or difficult functions. Some of the disadvantages of this prototype model is there, that is the client involvement is more, as it is in this quick design, customer involvement is there. So and it is not always considered by the developer. So most of the companies, they don't want to communicate with the client always, right? So they don't want to involve this client or the customer, or they calling that client or customer to the companies, right? So that is a major disadvantage, right? It is a slow process because it takes more time for the development. So after the design, so every time we are going for the prototype, development of the prototype, consultation of the customer, evaluation by the customer. So that's why it is a slow process taking more time for the development, and many changes can disturb the rhythm of the development team. So every time after this development of the prototype, any changes are done means they whatever the final requirements are there, it can be modified, it can be changed, right? It can be disturbed. So it is a thrown away prototype when the user are confused with it. So once we develop any type of the prototype, if the customer is not satisfied, as I said, if the client is not satisfied, then it can be a thrown away prototype again. So again we need to go for the development of the new prototype. That is the that are the major disadvantage of this prototyping model. Now next one is the spiral model. Nowadays most of the company are using this evolutionary process model. So a spiral model is the most efficient and you can say efficient development of increment versions of the software. A best example what we discuss is like Android versions, right? So the dramatic representation of this model appears like a spiral. Will show the diagrammatic. So you can see here, so with the loops, and you can say why it is called as the spiral. You see phases are carried out, or you can say the each and every phases are carried out, right? So The dramatic representation of this model appears like a spiral with many loops. So exact number of loops in the spiral is not fixed, and each loop of the spiral represents a phase of the software process. So for example, innermost loop might be concerned with the feasibility study, next loop with the requirement specification, and next loop for the design, and next loop for the coding, like that, so on, right? So each and every loop of spiral represents some of the phases of your software process, what we discussed previously, right? So each phase in this model is split into 4 sectors or quadrants. We'll discuss. So diagrammatically you can see here, it is divided into the 4 quadrants. Okay, 4 quadrants or 4 sectors like object identification, evaluations, okay, evaluation, product development, and next phase planning, right? So in this one, what is there, what is the important, so very easy process is there here. So for large projects also we can able to use this type of the model. As previously we discussed waterfall model, it is for only smaller projects. Incremental and rad model for the higher, when there is a demand or a short span of time, that time we can use that type of the models. But now if we want a complex software or we want large softwares, then that time we can go for this spiral models. So what is the importance here? First is in the object identification. In the first, you can say sector, first quadrant, the requirements are gathered, and what is the problem, what is the solution, you can say each and everything are provided in the object identification. Means the requirements can be gathered and what we can to this requirement. So once it is completed in the object identification, what is we need to develop, then it is forwarded. So in this phase we are going to do what? In this cost estimation, total time required, everything is going to be planned, right? So then it is moved to the next phase, that is the evaluation phase, which is most important part for the software development life cycle. So in this phase we are going to find out what can be the risk, right? Risk management can be done. So risk management can be done, or you can say what are the types of the risk we are going to expect, right, in this software development. So risk analysis or risk management can be done in the evaluation phase. Then prototypes, as I discussed previously, prototypes can also be developed here, right? So after the object identification, we'll go for the total time required, total team members required, total cost required for the software project, and what are the various types of the risk can be takes place, or you can say we are going to manage the risk, right? Identification of the risk is all the things done in the evaluation phase, right? Once it is completed, the important what we discuss in the iterative development, that is the product development. So after the requirement analysis, you can say it is forwarded to this phase, this phase, product development. So we will go for like designing phase. Already we discussed previously also, in the design phase one type of a structure or the architecture are prepared, right? Then similarly we will go for the coding, writing of the program, small units. Then we are going to combine it in the form of integration. We are going to do the testing part. Then we are going for the implementation, and we are going for the releasing of the application, right? So this is the called as the product development. Like in previous models also we have discussed, same way here also it is carried out. So after the releasing, and once we complete design, coding, testing phase, then we are going to release the application into the market or delivery of the software to the customer. So once it is completed, the last phase is there, that is next phase planning. Suppose if we release the version some 12.1, so here next phase planning means what is the 12.2, what features we can add it, everything will be added in this next. So in the next phase planning, so what is the new features, or what are the various features we can add it. Suppose for example Android 12.1 is there. So in the 12.2, what are the extra features are needed, and what are the bugs, defects or errors are there in this previous version, how we can remove it. So everything will be planned in this next phase planning, and they are going for the review, and simultaneously again the same process will be carried out. So that is all about your spiral model. So in the spiral model, we can say one type of if you want to release in the versions, different type of the versions, then that time we can use this type of the software development. Right. So already we discussed the various phases. It is going to determine the objectives and find the alternate solutions. So it means what, it includes what the customer requirements, right? Requirement gathering and analysis. So based on that, the objectives are defined, right, and different types of the solutions will be proposed. Then risk analysis in the second phase, risk analysis and resolving is there. So what type of the risk can be there, potential risk can be identified, analyzed and resolved. Then next one is the develop and the test. So all the phases, that is product development, so that is development test. So these phases include the actual implementation of your features. All the implemented features are then verified through the testing. So review, then finally last phase is the review and the planning. So next phase planning we discuss. So that's a review and planning of the next phase. In this phase, the software is evaluated by the customer, and it also includes what, risk identification and monitoring like cost overrun or schedule slippage, and after that planning of the next phase is started. So how much cost is there, how much cost expended, and whether the it is taking more budget for the releasing of the version, and what we can change in the next phase, everything will be planned in here. So that's why it is review and planning of the next phase. So now that's all about your spiral model. Now we are having some advantages and disadvantages about this spiral model. So it is, you can say, major advantage is perfect for large projects, complex projects, we can say, as I said earlier. So this model is very effective for the complex projects, right? And like continuous development is there, that time also we can use this type of the model. Because of its risk handling ability, the model is best suited for the projects which are very critical, like software related to the health domain, or you can say hospital type management softwares, like health domain related to that, or space exploration, right? That type of critical software can also be developed with the help of this spiral models. Then this model supports the client feedback, means the customer involvement is there, and implementation of the change requests are there, right? Customer can change his request, right? After giving his requirements, again after some 2-3 months he want to change, do the changes, they can do it. So this model supports that client feedback and implementation of the change request, which is not possible in the conventional model like waterfall model or other models. It's not there, right? So since customer gets to see a prototype in each phase, so there are higher chances of customer satisfaction. So as we are going to develop the prototypes, so that's why there is a higher chances of what, of customer satisfaction, we can say. Customer satisfied means then only we can move to the other product development space. That are the some of the advantages. Now we'll move to the disadvantages of this model. So it is taking more time. As I said, it will take around 6 months or 1 year also. So it is very expensive and time taking model, right? It is not suitable for simple and small projects. As already I said, this model is helpful for only complex and the large projects. For small projects we can't use this type of the model, and it requires the more and more documentation as compared to the other models. Why? Because it is carried out in the different types of the sectors, or 4 sectors, like starting from the objective identification, then we'll go for the risk management, prototype, then product development, next phase planning. So that's why it requires more documentation as compared to the other models. and project deadlines can be missed since the number of phases is unknown in the beginning. So we can say we can change the deadlines, like on particular day or particular month we cannot able to deliver the software to the customer. So because the phases are unknown right in the beginning, and frequent prototyping and risk analysis can make the things worse. So that are some of the disadvantages of this spiral model. So that is uh, that is all for this today's session. So in the next session we'll discuss about the third type of the model, that is the concurrent model, right? So and also we'll discuss the other concepts of the software engineering. Thank you.